So everyone, this is Pavlo. He will start with his lecture. Go on, Pavlo.
Okay, thanks a lot. So, zdrasti, or should I say zdravейте, if it was good enough. So, okay, so my name is Pavlo. I'm working for Cybertech. My official title is senior something consultant developer, but I'm doing a lot of things, like I'm a significant contributor to Postgres. This is the level of contribution. We have major, we have significant, and we want to introduce even more. I do like talks, I do community advocating and support and everything. So those are just like small part of our database tools. Some of those are under my maintaining. We are like distributed company. As you can see, we still don't have the office in Bulgaria, but I hope we will fix it somehow. Okay, so agenda. Today we want to speak about like different ways to monitor your database, right? So this is a full-time talk scheduled for 45 minutes, but we only have 30 minutes slot. So if I won't have time for live demo, please, and you will be interested, we have a booth for Postgres there, and I will have my laptop, and I can show you everything without hurry. You can ask questions, touch things, and anything else. So, okay, let's go for it. So, first question, why to monitor? Silly question, right? So, first of all, it's money. For me, I mean, not for me, but for me as an engineer, it's always money. How much do we spend on that, on that, on that? And especially in the time of cloud providers, you can have like 1,000 bill like for nothing. You want to know where your money goes. And of course, you want to be effective, you want to know your performance, blah, 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 but first of all, money, right? So if we will like try to understand what are the different ways to monitor the database, I would say we can split it into the levels. So the high level, then we want to see what's going on in our system, operating system or cloud or whatever, and then we want to know details inside our database. So for high-level service availability, I mean, yeah, it's silly, right? Who want this? I mean, just to know if our database is running, but that's like a common case. For example, in some Docker environments or if you're an application developer, you just want to know if the database is up and healthy, right? You don't care how many shared buffers or what is going on there. No, from the application performance point of view, I want to know that my database is accepting connection. If we are speaking about system monitoring, we need to understand what exactly we are trying to measure, what all the CPU, memory, and all other metrics mean to you. If you are running under hypervisor, or if you're running in cloud, or if you're running on the bare metal, you want to know what those metrics mean to you, to your database. And for Postgres specific monitoring, we can split this into three parts. First of all is a log. Then we have a special facility inside the Postgres called statistics collector, and we have a lot of different extensions that might help you to see even broader picture of what's going on. Many people that come from other databases or they just start the career, they're just like, okay, 21st century logs, really? Well, we have OpenTelemetry, Prometheus, and all these fancy words. But the thing is that everything that happens in Postgres always go to logs. Everything, whatever happens, you might miss it in some monitoring system. You might miss it somewhere. For example, crash. You cannot handle, like, you can't have the metric for crash outside of database, but you will see it in the logs. The reason, when, why, who to blame, right? And of course, we have like dozens of scripts and systems for the active like parsing. So first of all, we want to keep those logs for later analysis. Maybe we have some AI chat, right? That go through our logs and say, oh, we need to tune this and tune that. But usually we have like some kind of grep plus something. For example, the new thing here is PG Weasel, which is like implemented less than a year ago. It was presented during the PGConf Europe. Just try it if you want. Of course, we need to specify what exactly go to our logs. In Postgres 18, the latest version, we have 44 different parameters of how we can configure logging. What, when, minimal durations, the format, do we want it CSV, or do we want it in JSON, or do we want to have only errors, or do we want to have debugs, and so on and so on and so on. There are a lot of happening. So sometimes for investigation, you may increase some parameters, right, verbosity, and then for production, you may want to decrease those. Another gorgeous thing in a Postgres is a special part, is a machinery called statistics collector. The statistics collector is responsible for gathering all possible information in this system and provide it to you in views or tables. So you just can type select something from PG start activity, for example, and you will have like the list of currently working session, right? So, and we have like the division into two parts, so-called dynamic views and cumulative views. Dynamic views show you what is going on right now. It's just like temperature, pressure, right? I need to know what's going on, where to look at. And cumulative views, they're accumulating the statistics all over the time, and you can see how the metric changed all over the time. And that might be really surprising. So when you come to someone and you want to investigate what's going on, the first thing you probably want to do is to reset statistics, then run workflows like for a day, 2, 3, week, and only then analyze the metrics you have. Otherwise, your data will be like polluted with random like numbers, and you don't know what to do with those. Extensions. So Postgres is famous for its extensions. The must-have extension that we always turn on in any like system, production, whatever, this is PG start statements. It's easy, lightweight. It allows you to see a lot of things, that happens with your queries. And on base of the PG start statements, there is a PG start monitor extension implemented by Percona, which gives you even more. And I forgot to put it here because the new extension arrived like last week. It was presented on the European conference, PG Stat plans. So you can see different plans for the same queries and why they changed and what happened. PG Stat tuple will let you see inside your rows, are they bloated or not. Like auto-explain is good to see the plans for some of your queries, so you can specify the threshold after which auto-explain will produce output. So you will not pollute your like production database with a lot of explain plans. But for example, for 10% like longer than 200 milliseconds, I want to see what plan is, why, what happened, right? And then you can address these slow queries without touching anything else. Okay, so in real life, what do we have in real life? Life is hard, and every company has like their own implementation of monitoring. Usually, they all do log collection and parsing in some way. Usually, they all do like collection of the PG stat data, and then they do something with it. And alerting and trends. It's not important. I think that alerting is not part of monitoring. Monitoring is to see what's going on, to save this for later analysis. alerting is to react immediately, right? So nowadays, usually people use Prometheus alerting system, so it works well for them. And yeah, monitoring tools in the Postgres Postgres universe. So we have a lot of them. This slide was like trying to list most commonly used, but then I decided to replace it with just like the link to the wiki, because we have like 30 plus, and then they're constantly changing, and I mean, you will see if you will check this. If we will speak about real-time monitoring versus the okay, so real-time monitoring is when you want to see what's going on immediately, right, in your system, and you want to understand, are we fine or something is bad going on? So someone like run, I don't know, the import during the working hours, and we are like, I don't know, are out of CPU or disk or what. So for that thing, we have like a lot of open source real-time tool enabled, like pgactive, pgcenter, pgtop. pgadmin 4 is the GUI. The Beaver is another GUI made not by the Postgres community, but made by for different databases. So for example, this is how pgactivity looks like. Can you see it? So it's now on pause. If I will hold it from the pause. So, and let's start some things. Okay, so you can see that on the top, we have like the main information about our instance, the name, the version, how long it's up, the cache hits, all these things, like how many workers and all these things. Then we have like the main screen divided into tabs. On the first one, we can see the real-time queries as they are happening. On the second one, we can see the waiting queries if they are locked. Okay, sorry, waiting queries. And then on the third one, we can see like the queries that are blocked. That's sometimes we want to, you know, release the blocked queries. Okay, we can see the PID, like, let's go and kill the guy. Okay, pgadmin 4 has like, I would say poor support for like real-time monitoring, only 5 dashboards. But I mean, for the beginning level, it's okay. So you can see like major things there. The Beaver pretty much the same, only 3, but you can add your own dashboards. I never tried it, but should work. If we are speaking about continuous monitoring, that means you are collecting your data and then later you get back to it to analyze what was the reason and how to work with it. In this field, we have commercial and open source different applications, like all of them are mostly agent-based. That means that something is gonna running beside your Postgres instance and will send the data to the guy, right? And of course, like support for generic open sources, open source frameworks also there. Most of them based on the check Postgres. This is like the old famous script that produces the data and send it to the frameworks. Oops, sorry. So if we are speaking about Postgres specific monitoring tool, I can say about the PG Hero, the POA. So, and they are authors of several cool low-level extensions like PG QualStats, PG StatCache, and weight sampling, PG Clue. Oh, sometimes it's hard to pronounce those, you know. PG StatWiz, PG Watch, that I will talk about a bit later. So PG Watch, I told you that we have like 30 plus different systems. Why do we need another like one? Why do we need another PG Watch for that purpose? So first of all, I want to thank you, my former colleague, Karl Moppel. He is the author of PG Watch version 2. If you want to ask what happened to PG Watch version 1, nobody knows. Probably that was kind of, you know, Python script written in the basement by some wizard. Nobody saw this. We only know that there is a PGWatch version 2, and that's how we count our history. So the main principles about the tool. So it's supposed to be an external tool. You can run it with binary, or you want to run it with a Docker, right? Immediately, just pull and run. You want to change your dashboards. Someone needs one information. Someone needs another information. Someone has this kind of thresholds. Other has another completely thresholds. Or I'm just interested in absolutely different like workflows or whatnot. So you need to have the ability to change the dashboards. It should be non-invasive. So we are running somewhere in a cloud, somewhere in a basement. We don't know where our server is. The only thing you have is the connection string. But we need to have the ability to connect to it and to fetch as much data as possible. And even though you have no root access, or not root, but super user access, right? We need to have the ability to suck as much as possible without those special extensions. And if you know your database, if you know your workload, probably you know what exactly metrics, specific metrics you want to have. That's how we want to add the ability for you to create your own metrics. And yeah, if we are speaking about architecture, it's simple. It's just a Golang binary. We can provide configuration via Postgres, environment variables, YAML, whatnot. Then we have the concept of measurement sync. Sync is where our measurements go. So we are a database company, so we want Postgres first of all, right? Then, of course, Prometheus, it's standard de facto nowadays. Sometimes you want local file, especially nowadays when we have the access to all these beautiful AI agents that will replace all of us in a week or month, right? And we know that sometimes people want to have like this, you know, pretty interesting ideas how to use the data. So we want to have the ability to provide you with the RPC, which means that you can write your own binary that will be connected to the main PGWatch and will send you the data, and you will do with it whatever you want. Alerting, I don't know, archiving, what else? Like sending somewhere else, like make your ideas. Yeah, and we have optional web UI for administration, and we use Grafana for the dashboarding. So this is like the architecture. So the PGWatch is the small cube inside, in the middle of the photo, right? And as you can see, only one instance of PGWatch is designed to handle hundreds of instances, not databases, instances. So you connect them to whatever you have. Like the only limitation is the monitored sources must speak Postgres dialect. That means that we easily can monitor CockroachDB if only we know what to monitor, because they have like their own implementation. But I mean, all flavors of clouds, all flavors of Postgres, TimescaleDB, Citus, I don't know, just imagine what you have else. Everything works out of the box. When you have your measurements sucked, you want to send them somewhere. That's where the concept of sync comes, right? So you want to save it to database to analyze later, or you want to send it to Prometheus for your alerting, or you want to have like a local JSON files for archiving, and so on and so on. And later, on top of this Prometheus or Postgres measurements database, you can build Grafana dashboards that will later your management or your DBAs or your developers, so depending on what dashboards you have or you provide, you can split the access for different layers of the or departments. So yeah, features like we support all of the PG start collectors. So every major version, we update our set of metrics. So you may be sure that after each major upgrade, all new features will be there. Nowadays, we support Postgres 11 and higher, but for you to remember, the latest supported officially Postgres version is 13, right? And it will be discontinued next September. Okay, so what else? We can set up the auto discovery. Nice feature. For example, you have a database where you create, or your clients create new databases sometimes, right? You don't want to track all the new or deleted databases every hour, right? So you can say the mode auto discovery. So the PG Watch, when it collects to the database and when it fetches the metrics, it will check for the new database objects on the instance, and if new databases are found, it will automatically add those under the monitoring. So you don't need to do anything, like new databases arrived, it's already in monitoring, right? Beside of the Postgres metric, out of the box we support PG Bouncer and PG Pool pullers. Also, we have support for Patroni. So, for example, if you are running your Patronic HA cluster, right, and you have like dynamic structure in it, you can say, okay, so please follow the architecture of this structure and then add under monitoring the nodes depending on their roles, right? So if we want to apply full monitoring to the primary node, we probably are okay to have a minimal monitoring to the replica. We don't want to stress it so much. And if failover happens, or switchover, PGWatch can handle the situation. Okay, so now you are the primary. Okay, so now I will ask the full set of metrics from you, and you are chill, right? Yeah, so alerting, as I said, so nowadays Grafana is one way to go. I don't like it because like it's kind of it's not the purpose of the Grafana to send alerts. But I mean, yeah, so Prometheus is usually a way to go for alerting nowadays. I never saw something else unless you have your own written scripts or systems. Another one is a PG timetable. I'm a maintainer of PG timetable as well. So with this one, you can just access the database, check the measurements, apply your logic, and send alerts like in emails, Slack, whatever. Among other things, so very cool thing we found with the timescale DB and the Citus as well. So any forks of Postgres that provide you with the compression are very good to use for measurement databases. So for example, if we take 6 databases under monitoring for 3 months, it will produce 45 million rows. And if we use like the vanilla Postgres, it will take 70 gigs for 3 months. But do not be scared. I mean, the automatic retention period is 2 weeks. So we just stress the system and see what's going on. So if we use like timescale DB with a compression, so the ratio is 9. So we can compress from 70 to 8 gigabytes. And right now we are working on the feature where we can even increase the compression just in case if you want to keep your data for a longer period of time. Another cool thing is the parallel syncs. So if you want to have like the best of the world, if you want, for example, you may send your measurements to the Postgres, right? Or for alerting purposes, you want to say the same measurements to Prometheus, or for the same purposes you want to, or for the same reason you want to save to local files to look at it later, or you have different set of metrics. One is for management, another for DBAs, right? You can have those. So one is going to one instance, another goes to another. And Docker images. So as I said, the first idea was we need to have a Docker image. So when I come to a client, I don't have a USB stick with me, like compiling everything. I just say, okay, this is the connection string. Let's suck the image. Let's start it, and we will see. So we have two Docker images. One is PGWatch demo, which is the big one, because you have everything there packed. So you have Postgres, PGWatch, Prometheus, Grafana, everything in one package for you, so you just can run it and see, to touch it, how it goes, what's going on inside, right? And we have a special image for production, PGWatch only. It's only 44 megabytes, easy. In this case, you are responsible to have your own storage, you're responsible to have your own Grafana, which is usually you do if you're working in the tech company, right? So it's easy to start, like if you want to see how it looks like, you start the PGWatch demo, and you can see what's going on. Or you can go to demo.pgwatch.com, and this is how it should like. So we have 2 minutes left. I will show you some dashboards, and later you can come and I will show you more. So this is one that most people love the most. I call it all green, right? So we have a lot of metrics. You set your own thresholds, and you want to be sure it's usually somewhere in the corner on the big screen, and you're just like sipping your coffee. I'm fine, all green, right? The next one is when we start to see what's going on instance. This is the first level called global database overview. On this level, we can see what's going on instance level for all databases, right? For resource consumption and all other things. If we want to go even deeper, we have a database overview. Here you can choose for which database we want to see what's happening, right? So here's the monitor source. We can test it, we can change it, and we can see, okay, so this database is having these issues and these issues and whatnot. Of course, after that, the question comes, what is with our performance? And for performance, queries are responsible things. So we have a special dashboard where on top you have a list of top 20, in this case, top 20 queries, and you can filter and sort by average time, average call, blah, 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 CPU consumption, and whatnot. And you have a query, and if you click this ID, you will go into the detailed, okay, let's click it. You will go to the detailed query overview. So we can see how query behaves over time, right? How many calls, how many total runtime, shared buffers, missed buffers, all the things. And on the top of it, you can have your like the same top 20 things, but here you can see those on graphs, right? So you can visually see what happened here. And the last but not least, the table overview. This is like the same for queries, but for tables. You can see size, you can see the change of size, less vacuum, less analyze, and yeah. And here at the bottom, you can see like visually how big one table comparing to another. So the same here, if you like click on it, you are going to the detailed overview of the table, and you can do a lot of things. Okay, so I'm out of time. I will love to see you at our booth, and I will love to answer on your questions. Thank you.